Welcome everybody once again to our session 12. This session 12 um, of week 6. Yeah. So this is the second class for week 6, and this is the 12th session for the program. And we are actually making progress. So today we are going to wrap up with what we started yesterday, that's Matplotlib. And before we do that, we'll go over the assignment very quickly, because I don't want to spend so much time on that. So, and then we'll move on to introducing machine learning to us, and we'll move from there. And next week, we're going to continue from where we stopped today. All right, so I'm going to share my screen now. Just give me a minute. All right. All right, so I'm going to be going through the assignment for week 5. For those of us that might still not have seen the grade, I'm still marking the assignments. And we will see it once I'm done. So don't bother yourself about that. You get it once I'm done marking or grading them. All right. So for this particular assignment, it was supposed to assess you on pandas, right? So that is week 5. We treated pandas last week, so this should help you understand and practice some of the concepts that we talked about. This particular assignment was a challenge for some of us. I even had um, to bring out time to help resolve some issues that we were having, right? So I would want to just just advise that we try as much as possible to go through the instructions first, right? And listen to the things I say that are very specific in class. So because some of these errors, they are obvious errors. It's probably due to you not naming your file well, or it's probably due to you not using the right command or the right function. So there is nothing else that is outside of that. If you do everything correctly, you shouldn't have any problem. All right. So you shouldn't have any problem because plenty of us were able to submit our assignments, even while some persons were complaining. So I understand that we have different configurations on our system and so many other things. Some of us might not are not really computer savvy like that, which I understand. But please just try as much as possible to listen to the things I say in class, right? So those are the things that will help you to navigate easily, navigate the entire you navigate the assignment and whatever it is you're being given um much better. All right. So for this particular assignment, it's based on a data set I sent. Right, it is based on a data set. So give me a minute, let me turn this notification off. Just give me a minute, please. All right. Okay, so it's based on a data set I sent to the classroom. Right. So most of us had issues with this, so I think we will not be needing this again. This was the initial file I sent. So the data set we have here is a customer booking data set, containing information about airline bookings, including number of passengers, sales channel, trip type, purchase lead, and everything here, right? So I believe we read that. So based on this data set, you have to provide answers to each of the following. So I needed you to provide me the shape of the data frame, how many columns have null values, and how many duplicate records are in the data set. So after figuring that out, then remove the duplicates and rows with null values, and also remove these two columns, purchase lead and booking origin. So this is basically you doing data cleaning. So you are cleaning your data, right? So I also asked, what are the different data types we have in the data set? And then what are the different trip types available to customers, and which one is mostly used, and which is the most used sales channels for booking. So these are basic questions actually. If you're in the class, it shouldn't be a problem to you. So most of the techniques we talked about in the class, all of them can actually be used to answer these questions, right? So I'm just going to go through it as quick as I can. So now you import your libraries, and then read your data sets into a data frame. So some of us were using print. I said this several times. We're using print to display um our data frames, and this is what it shows me. I don't like whenever I see this. It doesn't. It's not intuitive, right? So always ensure that you use display. That was why I um introduced this function. So it will appropriately render your data frame in a very good format. So it will be easy for you to visualize and see what you're working with, right? So please take note of that for subsequent assignments. So first thing to do, obviously, is check the data frame to see exactly what's there, right? So the first question, understand your data frame. What's the shape of your data frame? And this is it. It has 50,000 rows and 14 columns, as simple as that. And you use df.shape for that. So the next question is, how many columns have null values? So I taught you how to get null values in a data frame, and there's something you should know. You can either use is NA to get it, or you can use is null. So pandas have two functions for getting null values. So is null can be used, and is NA can also be used. I was actually impressed with some person's assignment because some answers were done with some functions I didn't talk about in class. That is really telling on how far we are reading and how much time we're dedicating to practice what we are learning, right? So there's some things I saw like I don't think I talked about this in class, and it was nice. Yeah, it's actually very nice. So and this particular is N. I don't think we did that. What we did what is null. So is N can also be used for null values, right? So also duplicate values. I told you the functions to use. So you can use duplicated and then aggregate it to sum. If you just use it duplicated, you're going to get false, a Boolean mask, as I told you, right? So I'm not going to go into that again. So these are the null values in the different columns we have. So as you can see them here, we have a lot of them, and you need to clean them, you need to remove them, right? In this case, I asked you to remove them. You can actually do other things, right? You can replace them and do other data cleaning techniques. So we have 735 duplicate values. What this means is that each row, there are rows that are duplicated 735 times. So you have to drop it, right? Because these are like basically redundant data. So you don't need to have them. They're going to skew your results or your insights, right? So there was a particular. Okay, let's just move on. Let's move on. So as you can see here, the data set has 735 duplicated rows and across the 14 columns, right? So I also asked to remove two particular columns, right? Remove once you've gotten the number of duplicates, Can no audio, please let me know if this is a general problem or you all can hear me. Please confirm if you can hear me. Hello. All right. All right, great. So please, I don't know, network can be bad sometimes. So please just try to adjust your network settings, right? So you do not miss what we are discussing. All right. So after getting the number of duplicates and the number of null values, you now have to remove them. So you can see the functions for that. So we'll drop the duplicates and also drop the null values using these functions, right? So this is important to add. Either you use in place or you assign it to a new variable, right? You assign it to a new variable. You can do that. You can use either of this method to perform this operation. So there was a particular assignment I saw. I believe it was not just one person. They dropped the null values, but they didn't indicate in place equal to true. So it was not affected. And when you come here and because I asked to get the new data frame shape, once you get here, you are going to see that the shape is still 50,000 and something and 17. So you basically not answer that question. So it's important that you pay attention or you understand all these details that we talk about. So in place is very important for you to effect the change in your original data frame, right? So this is just it for that. You drop them and as you can see, we've dropped and there is no other null value here. So we'll move on to the next question. So this basic, very basic question, the different data types and the different columns. So as you can see, these are what we have here, right? So can't hear. I don't know what's happening. So many persons can't hear. What is happening? Okay, let me see. Blessings, Sulaiman. Please try to reset your network. Try to reset your network. This is I think it's peculiar to you. Others can hear me, and I feel my network is okay. So it should be from your own end. Try to restart. Either you restart Telegram or you reset your network, right? So you can join us on what we are doing. All right. So yeah. Give me, I don't know why this thing is making noise. Let me just get rid of it. All right. So please just give me a minute. Just give me a minute. I'm trying to ensure that this doesn't make noise again. All right. So let's just continue. Okay. So that's it for question 4. Then for question 5, we have the different trip types, right? Available to customers, so you know how to do that. So to get the different unique trip types, you use this particular function, right? So you can see we have round trip, circle trip, and one way. And I asked to get the trip type that was mostly used by customers. So you can use the value count function for that, right? So and you get this particular value for each of them. So remember, you can all as well do normalize equal true, normalize equal true to get it as a percentage. So you can get them. So as you can see, this is even giving you a better understanding of it. 98 To get it, you can actually multiply the result by 100 as this person did here, which was quite impressive. So you can see we have 98%, 98.9%, which is almost 99%. So this actually gives you a better insight into how much passengers uses this round trip. So almost every passengers used round trip type, trip type. Just few 0.7% and 0.2% of the 50,000 customers that we have in our data set used either of these ones. So this is another thing you can do, right? So just explore. Don't limit yourself to just what we talk about. So as you can see, you can do this and then multiply your result by 100, so you get a better understanding of the result you're seeing, right? So now I also ask for sales category. The same thing, you can do the same thing here, right? So if you do the same normalize equal to true and multiplied by 100. So you're going to see the internet is 88.7%. Pi mobile is this. So basically, most people use their, I think, computer or something, website to purchase their ticket, while others use their mobile phone to do that. So all these are just ways to get insight from the data. And this is another one. So right, just these are just basically the same thing. So if you were in the last class, this shouldn't be a problem for you, right? So let's go over what you've missed, where you need to correct yourself and do that. So these other ones are still the same thing, right? So the flight days, I taught you how to group by a particular categorical variable and aggregating by a particular numerical variable using an aggregation function. So depending on the question, to determine the kind of group by you are doing and the kind of aggregation function you are using. You can use sum, you can use count, you can use mean. You can show you there's so many of them, right? So basically that is it for the assignment. I would not waste much time on that because we have things to do today. So you get your grade just whenever it is ready, you'll see it. Right. So for the next assignment we are going to be having this week, it's going to be a combination of pandas and matplotlib. So as you're getting your insights, you are displaying them in visuals, right? So you are displaying them in bar charts, in pie charts, in scatter plots, in histogram, right? So you're going to be using these visualization techniques that we talked about yesterday, right? And the one that we're going to talk about today to do that particular assignment. So it's going to be almost like a data analysis project, right? So you're now getting to understand how you do data analysis in Python, right? So you are getting a higher level understanding of everything. So by God's grace, before we are done or when we are done, you'll be very confident with your skill in Python. So and that is exactly the aim of this program. So that's it for the assignments. We're going to go to what we have for today. So we're going to be looking at machine learning. We're going to be looking at machine learning. Let me change my network. I don't know if it's a problem. All right. All right. So now I'm going to be introducing machine learning, but I feel we're supposed to finish up with matplotlib before we enter here, right? So let me quickly see that. So, yeah, I remember we didn't talk about histogram yesterday. So I'm just quickly going to talk about that and then move on to machine learning, right? So All right. So today we'll just look at histogram and move on to where for today. So we talked about all these other plots, pie charts, scatter plots, bar charts, line chart, right? And today we're going to look at histogram, right? So basically what histogram is used to do is to review distribution of data within a specific range, right? Within a specific range, and it is usually used on continuous data. So if you've watched the video I sent you regarding data types, you understand what we mean by continuous data. So basically continuous data are numerical data that are basically, yeah, basically numerical data basically. Most of them, they're mostly in decimal format, right? So they have an infinite range of values. So for instance, we can have maybe a variable that talks about the income distribution or the income of each person, right? So we can also get so many things. So in this particular data we have some numerical data there, right, that we're going to use to for this particular histogram. So how we do the histogram in Python or in Matplotlib is similar to how we've been doing bar chart and the rest. So you can see the example here. We use plot.hist, right? Plot.hist. And then we also give our data, input our data here. And we have other color arguments or parameters in that particular function. So let's quickly use this example to illustrate how to create an histogram in Python. I sent the data type video on the Google Classroom. If you go there, you see it. I think you should check week 5 video, week 5 topic or week 6. It should be somewhere there. So we're going to import matplotlib dot pyplot as plot, right? So we also import pandas as pd, and I'm going to import matplotlib dot style. So this is for our the style we're going to be using. So I want to use style.use ggplot, right? So yes, that's what I want to use for my from the same thing. I don't know why the same format. All right, so we'll bring in this data we have here. Right. So let's assume we have this particular set of data, numerical data. I want to plot an histogram to see the distribution, right? You can basically just use the plots. Okay, let's create our figure first. Let's use figure size, fig size equal to, let's say 8 and let's say 6. Oh no, that is wide. So let's use 7 by 7. All right. So we've initiated the figure, like defining. Let's come here and say defining our figure and its size. So if you don't want a specific size, you can skip this process. You can skip it. Matplotlib will automatically create a figure and a default size for you. So creating the histogram. You can just say plot.hist. So this hist function is what we use in plotting an histogram in matplotlib. The same way is the same way we do plot.bar, same way we do plot.py, the same way we do plot.scatter. You can also do plot.hist. Right? In case you forget the function name, you can just say print dir and say plot. So never forget the dir function is very, very important. So you can just go, everything is arranged alphabetically. So it will help you locate it. So remember, you want to plot histogram, you go to where H is, and then you see, okay, see hist. Okay, this is what it is. So it's hist, because it's very, very easy for you to come here and say, remove this. It's very easy for you to come here and say plot.histogram. Maybe you forgot the function name and you thought it was histogram. So you just come here and histogram. If you do this, it will give you an error, right? Module blah 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 does not have attribute histogram. So you have to understand how to search for all these functions, right? So we've created our data here, this one we have here. So we'll just pass it into, so what we need to pass in the histogram is just one single data point, right? Just the numerical variable. So pass it there. Let me take this up. If we pass it there, this is what we're going to get. We're going to get an histogram, something like this. So this is, because of the data, we're having something like this. So let's say I come here and I try to create another data, right? Using random, I'll come and say import numpy as np. Right, so I can come and say data is equals to np dot random dot rand n, right? So in case you forgot exactly what to put there, you can just put the question mark. It will tell you exactly what to do, right? So giving the explanation here. So I think this one is quite different. All right. So but what this random, it gives you value between 1 and 0 of a particular size, right? Right. So it gives you values between 1 and 0. So if I make it, let's say 4 by 5. So I'm going to get something like this. So I can basically just flatten it to a one-dimensional array and assign it to data. Right, so if I come here and plot data again, see I'm going to be getting something that's different. So based on your data, you would have a different shape and distribution. So there are a lot of things, other things you can do on your histogram. Right, so we come here, you see we have a particular parameter here called beans, right? We have beans, and the beans is basically this. I explained what it is in the last class. I said the bean is each of this bar that we have here, right? Each of the bar is a bean. So if we say the bean that we want is equals to 5, we have just 5. If we say equals to 10, we have just 10. So you can indicate the number of beans we can have in our histogram. So if I come here and say beans equal to 10, it will give me this. So this is 10 bean, which is usually the default. If I say equal to 20, I'm going to get this. I'm going to get more beans. So this particular data now, it doesn't really make sense, right? So that's why you're having this, right? So once you are working with a normal data set that has a particular distribution, you're going to see a different distribution, a different histogram based on that data. So yeah, that's just it for that. Right. So let me see if I can make this like plenty. Right. So as you can see, we're having a different distribution now. So you see, it is now making sense. So this is what we call normal distribution. So the data point is plenty, so we can aggregate as many as we can and get a defined distribution. So as you can see now, we're having something that makes more sense. Right. So I would also send a video. And the reason why I'm doing this is because we don't have enough time to go deep into statistics, right? So there are some statistical concepts that you need to understand as regards distribution. So we have several kinds of distributions, right? So we don't have enough time to talk about all those. So I will also send a video that will describe the kinds of distribution we have. And histogram is one of the visualization or one of the techniques we can use to explore the distributions of our data. Right. So now this one here is what we call a normal distribution. It is called a normal. So I think I'll just explain what a normal distribution is, because that is the most common distribution that we have, and that is what you mostly be encountering. So a normal distribution is a distribution that um, is part of that you observe basically in the natural world, right? So if you sample the height of 100 persons, or let's say you sample the height of 500 persons in your community, 500 persons, and you plot the distribution, or you plot that data in a graph, in a histogram, you're going to get something that looks like a normal distribution. So what this means is that this center point here that you're seeing is the mean. This is the mean, right? So the other values you are seeing are the values to the left of the mean and to the right of the mean. Let's assume you get height of 500 students or 500 persons, and the mean height is, let's say, 5.7 feet, right? So that's what we're going to have here. Majority of the population, we have the mean height. Their height would be around the mean height, right? While like fewer or lesser people in the population will have their height to the right of the mean, maybe lower than 5.7. So basically what it means that if you, let's say in a particular day, you just sit down outside your house and you just say, today you want to observe the height of the people that passes by. That is your work for that day. So this is what is going to happen. Let's assume you record each person's height. So as each person is passing, you will see some people that are tall, some people that are short, some people that are just average height, right? Now, the thing about a normal distribution is that if you sit down and you observe that for, let's say, the whole day, you observe that the one you saw most was the people with average height. So that was the most frequent height you saw, right? So the people with average height. So you saw people that are tall, right? And you also saw people that are short. But the ones that you saw most frequently are people that are average. So that is how it is in the natural world. The average of a particular variable is the one with the most frequency, right? The same thing for weight. If you sit down again and you say you want to observe the weight of people, what you're going to observe mostly are those that are normal, they have normal weight, another fat or slim. So the people that are slim, you will see them. People that are fat, you will see them, but they will not be as common as people that have their normal weight. So that is the real life distribution. And the real life distribution is a normal distribution. If you plot the values of the height that you saw and the values of the weight that you saw, you're going to be getting this kind of distribution, which is called a normal distribution. So I just need you to understand that, and just understand what a normal distribution is. It is a natural phenomenon. So any variable you can think of, any continuous variable you can think of, you are going to always. It is also almost always going to be a normal distribution, as long as the sample size is large. So another example is if we have, let's say, 500 students that sat for an exam, right, and they took the exam and they got their result. Plotting the result or the grades of those students in number, right? So let's say it's over 100, and you're plotting it in a histogram. You're also going to observe a normal distribution, meaning that most of the students had average scores. It's just few of them that had very high score, and few of them had very low score. So that is how it is. So everything, intelligence is normally distributed. Everything you can think of, your even if you can represent economic status in a histogram or in numerical data, you're going to observe that it's also normally distributed, right? The people that are you have more average people than in middle class, and more less persons in higher class, right, and lesser person. So that's basically how it is in the real life. But it's not always perfect. It is not always perfect. So, but it is almost always normally distributed. So I just needed to say that so you understand the importance of histogram. Although still going to send a video explaining normal distribution, right, and all that kinds of distribution. So all these things is something that you might need, right? This normal distribution is something that you need to know. You need to know it. So that is why I actually took a minute of our time now to explain it. Right? But other distributions that we have, as you move on and as you go deeper into data science and working with data statistically and all other things, you need to understand other kinds of distribution, right? So just put that at the back of your mind. You can go further and read, go further and explore all these things I'm just saying now. Right. So that is it for histogram. So as you can see here, this particular function random.randn. The reason why it is normally distributed here is because this random.randn function is creates a normally distributed data. So this n that is here means normal. This n that you can see here, rand n, is normal distribution. So we have random.rand, like just rand without n. So if we plot that one now, let's see the kind of distribution it will give us. So if you want to remove all these things that you are seeing, all these numbers, so you can just say plot.show, right? It will just give you only the visual. So you can see now that this distribution is not normal. It's not a normal distribution. It is, I don't even know what distribution is. I think it's almost a uniform distribution kind of, yeah, but it's not a normal distribution. So this function here, rand n, is going to kind of give you values or data that is not, that if you plot it, it is normally distributed. So you should just keep that at the back of your mind. So remember when we're talking about data science, we talked about the different field. It's a multidisciplinary field, right, that encompasses statistics. So statistics is what we are doing now and what we've been doing. All this mean median mode that we've been doing, right? All those things are statistics, standard deviation and the rest. So this one I just explained now is also statistics. So it is mixed, it takes from all these fields, takes from them to make up data science. So I just have that at the back of your mind. So now I'm talking about the histogram. So now we can change the beans value. We can make it 30. You can see it to be smaller, right? We have much more smaller. So everything, if you count the beans here, they are 30, right? So if we make it 40, you see it is smaller. If we make it 100, let's make it 1,000. It's that's impractical. So you see it's very, very tiny. So basically you just need to know the number of beans you want for your data, and you use it appropriately, right? So you can just leave it at 50. So there's another particular parameter that we have here. It is called what is that? Edge color. So see it here, it's called edge color. So if we use that for edge color, I think that should be right, correct. So it's going to give us this separation, right? As you can see, this is what we saw in this particular chart here. So this is what most of you were expecting to see. So yeah, it's exactly the same thing, just that the previous one didn't have the borders separating each bins. So if you count these bins now, you see that they are up to 50, right? So basically that is what edge color does in the hist function or the histogram function. Yeah. So I think there's also another parameter, color. You can change the color. I don't know if it applies here too, but yeah, you can change the color of your charts to any color you have. So there's something you need to know, like for each of these, I hope everyone can see this. I'm trying to zoom out so you can see the graph better. Can you see the text, the code I'm writing? Please let me know if you can see the code I'm writing here. All right. So you have so many parameters here. To explore them, you can basically, yeah, I'm going to zoom in. Don't worry, I'm going to zoom in. To explore them, to explore or see more, you can just come here and say plot.hist with the question mark, right? So it's going to give you all the parameters for that particular function. So you see we have X, which is your data. We have bins here, right? We have range, right? You can specify the range. You have density, you have weight, you have a lot of things, right, that you can tweak and play with. So you can see we even have orientation, right? We have color. So this is the color we just used. We have there are a lot of them. There are a lot of them. Even if we check for bar charts, you see a lot of them. So bar chart just have X, height, weight, bottom, float. Right. So check for scatter. So I just want to advise you to learn how to use these helper functions in Python, IPython. So they'll be very, very helpful when you need them. So now let's see one of the functions in this list from one of the parameters in this list. So we have the orientation. Orientation now by default is what? Vertical. So anything they put equal to here is the default value. So if you do not indicate any of these parameters, this will be the default values. So these are the default values. So these are the options that we have here for each of the parameters. So let's play with them. So let's just come here and say for the orientation, we want to change the orientation to horizontal. So before the normal default is vertical, which we have here vertical. So if we come and say orientation, I can just bring this down here. So say orientation equal to horizontal, right? So if I plot that, you see I'm going to get it. It is flipped, but this doesn't make like I don't know the case that you would use this, but this is what you can do with all these arguments. So you can play around with them. You can just go there and see the things that you can do with them. All right, so that's it for histogram. All right, so we can basically practice on your own. But let's quickly see how we can use it in our data. So let's bring in our data df.read CSV. Let me see if my data is still here. Customer bookings, retail transaction, retail transaction.csv pd.read CSV. All right, so we have our columns, the types. I have a float here, quantity, price. So I want to see the distribution of price right? And I want to see the distribution of quantity and also discount applied. So let me come here and say, I'll say price is equal to df dot price quantity is equals to df dot what quantity, and then discount is equals to df discount applied. So you'll be wondering why am I not using the dot for this. So this discount apply has a symbol that Python can interpret. So you don't use it like that. You put it in a string, so you can. But if you leave it, what is the name of this particular symbol in Python based on what we learned initially in the beginning? Can someone tell me what's the name of this particular symbol in Python? We learned this in the introductory part of Python. Now some people are saying module. Yeah, it is modulus, not module. Exactly. So yeah, so we still remember. That's great. That's great. So and what does modulus do again? What does modulus do? What does modulus do? Can someone tell me? Exactly, exactly. It gets the remainder, it brings the remainder. That's great. At least we still have we are still conversant with what we've been learning so far. That is impressive. Right. So basically when you have this kind of symbols in anything, you make sure you just put everything in string in quotes so Python doesn't interpret it or something. So now we have this all this particular variable. We're going to plot each of them in a histogram. So we can come here and say, I'm going to demonstrate something, but let's go on. I will say plot.hist, and I will say price. I will now come and say plot.show to remove all these numbers I'm seeing here. So now we are seeing something. We are seeing something. Can someone tell me why we have only one bar here? Only one bar. Let me see. Pins is equals to 100. Can someone tell me why we're having only one bar here? Anybody? Anybody? Okay, okay. So basically it means that this particular value here has a very, very high frequency compared to other values. So it is so high that in comparison to other values, histogram cannot even compare it side by side. So you would have to do a kind of data cleaning in this case. So this is a pointer to something about your data, right? So you have to do data cleaning. So yeah, you can now start to see the importance of visualizing your data. So it helps you see some things that you might not even have seen just by looking at your data, right? Yeah, so let's look at quantity. Is that correct? So this is so now this is a very weird histogram because now this quantity is a finite range of number. Right, so I think we have just 1 to 9 in our quantity. So plotting it in a histogram won't make sense. So if you think all numerical data can be plotted, you would actually have to think again. Right. So as I said before, continuous numerical variable. So those that particular video on data essence, please ensure you go back to it and watch it. So you can now start seeing the way these things are, like just by visualizing them, and it's giving you insight into your data So let's check this count. All right. So you can see this count. See how it is just scattered everywhere. You can't really see a normal distribution in this particular you can't this distribution doesn't look normal at all, right? So these are just the things that you can do. There are a lot of things we can discuss about a histogram and normal distribution, but we'll just leave it at that. So in this particular data set we have here, we can actually do or use the histogram on to get any meaningful insight from these things. But for this price zone, you can basically still clean your data to get something meaningful. But because of time, we won't be doing that. Maybe you can try that on your own, right? So these are the things in visualizations, right? So this is basically what visualization is. So the list of things you can say plot dots. All right. So I said something about subplots yesterday. So let me see if oh, okay. Yeah, don't worry, we'll do that later. It is almost 6 and we need to enter machine learning. All right. So that's it for data visualization for what we have, right? We've looked at what we have here. So for this heat map, don't worry yourself. You'll see it in action when we start our machine learning course. But we can as well just copy this code just to give you an idea of what it is and come and paste. So this is what heat map usually looks like. So it's a kind of range of color. So this one doesn't really mean anything now because the data here is just a random data, like so it doesn't really mean anything, right? So it's when you're working with the data set, you need to get insight from that. You can now start interpreting the colors, the intensity of the colors in this heat map to mean strong correlation. So this is how it usually is. By the y-axis here would have a particular variable, usually a continuous variable, a numerical variable, and by the x-axis here. Remember I told you x-axis is here, so whether up or down, as long as it is horizontal, that is x-axis. So whether here or here, so just get understand that. So your y-axis you have a variable, your x-axis you have a variable. So you can basically plot a heat map to show you the relationship between these two variables, and it will be coded in colors. So the color here, if it's very intense, there will be a legend here telling you explaining what the colors mean. So this particular color, if it's very intense, it shows you that there is a very high correlation between these two. So let me just go into that. So this is what we use heat map for, and don't stress yourself about it so much. But if you want to look at it further, that is very fine. There are resources out there for you. But we'll look at that later on as we move on. So let's move on to what we have for today. I don't want us to take anything over next week. So today we'll be looking at machine learning, right? Introduction to machine learning. So now this is another different phase of this data science program. All right, so we're now moving on to a more technical part of data science, and trust me, you're going to enjoy it. Trust me, you are going to enjoy it. But you just need to be very attentive, right? And you also need to practice. So we'll be looking at a lot. But for this particular class, they will just be introducing us to machine learning. So far, we've gone through Python. We've looked at the basics, the basic concept in Python. We started from variable. So sometimes when you just think or when you want to just think about how far you've come. Remember when you started. For those of us that didn't have any prior knowledge in data science, remember when we're battling with variable, when we're battling with data types, integer, floats, asking questions about modulus, floor division and the rest. Now you are here, you can do analysis, you can visualize data. That's a big step. Like you've grown, like you should actually be proud of yourself. So you've dedicated time, you've dedicated effort, and you are seeing result already. So from that time to now, we've achieved a lot. You have achieved a lot. So now we are entering another, I would say another phase of it. This is machine learning. Machine learning is a whole different thing from what we've been doing before, but it's part of it. So it's a technique used in data science, right? But machine learning itself is a field on its own. So there are people that we call machine learning engineers. Just the same way we have software engineers or software developers, we have machine learning developers or machine learning engineers. So these people, they work on machine learning algorithms. They do everything that has to do with machine learning. So they are actually different from data scientists. A data scientist applies the tools of machine learning in extracting insight from data. So you need to understand that difference. So we're not just doing machine learning just because it is cool and just because it is interesting and we want to challenge ourselves. As a data scientist, you are doing machine learning because it is a technique that we can use to make meaning of our data, right? So that's what we're going to be exploring. And it's a very vast field. So don't disturb yourself about understanding everything in it. Don't disturb yourself. So just have the fundamental knowledge. And as you are growing, you'll be learning it step by step. So at this point, don't expect to learn every single thing about machine learning. So it will not overwhelm you and you will now become frustrated. So have set that realistic expectations that, okay, so machine learning is a very vast field. I will take it a step at a time. I will try to understand the fundamentals very well before moving on. So once you're done with this program, you definitely have the skills to perform some to do some things with machine learning, right? But once you are done, you shouldn't just stop there. Although as you are applying for jobs, you should also be learning and growing and learning new things in machine learning. As I am now, I'm also learning. I'm also taking courses on advanced machine learning techniques, on deep learning techniques, AI, and the rest. So there are things that it is a deep water. It's like the ocean. It is endless. So every day they are bringing in new things. So that is it for that. And today I'm going to be introducing you to machine learning. So as you can see here, I added some illustrative picture just to help you understand it and appreciate it better. So this is, okay, we have a human brain here and we have a kind of computer brain here. So it's already give you an idea of what it is. So the same way human can learn, the same way computer can learn. All right, so you'll get to understand as we move on. So for the outline, we have overview of machine learning, types of machine learning, steps in a machine learning project, core machine learning algorithms, model evaluation techniques, practical application, and machine learning libraries. So I'm going to try as much as I can to cover everything in this class. I will try not to be as fast as possible. So because this is a new concept and you need to have it flow. So I'm just going to try to take it step by step and bit by bit, right? Now the learning objectives here. You should understand the fundamental concepts and importance of machine learning. You should learn about different methods, including supervised, unsupervised, and reinforcement learning. You should know the life cycle of a machine learning project from data collection to model deployment, right? You should also know the essential algorithms like linear regression, decision trees, and neural networks. So all these things is just the surface level that you should know, right? You don't need to know the details of linear regression in this class, just to understand that these are the algorithms that we use in machine learning. And you also know what evaluation of ML models is. So we are going to be introducing a lot of key terms and new concepts to you that might sound strange. To some of us, it might not be new. To some of us, I believe the majority of us, it is new. We are just sharing this. We might not be hearing this for the first time, but we are actually being introduced to this for the first time. Before I proceed, please let me know in the group chat if everyone can still hear me loud and clear.
Yes, we can hear you loud and clear.
All right, great. So now, what exactly is machine learning? Right? What exactly is machine learning? I've just given you an overview of it, right? Just a tip of what we are to expect. But machine learning itself, what is it rather? So machine learning is a branch of artificial intelligence. Now, another thing, we are now introducing another thing again, artificial intelligence. Let's pause there for now. That focuses on building systems that learn from data. So this is very key, that learn from data. So now this is where we come in as data scientists, right? The reason why we are learning machine learning is because data is involved, right? There are a lot of things that we can do with data, and the algorithms that can help computers or machines to learn, and just like a human being will learn. Don't I would give you an example as part that pertains to us, so you can have an intuition of what machine learning is. But just follow me here. So these are the things you need to know here. It's a branch of artificial intelligence, right? That focuses on building systems that learn from data, identify patterns, and make decisions with minimal human intervention, right? So, the significance of machine learning lies in its ability to perform complex computations and process vast amount of data at a speed and accuracy that human cannot match. So, we will look at all this, right? So, but just be taking note of what I'm saying, right? So, this is just basically the introduction to what machine learning is. So, if I zoom out, you're going to see the interaction or the relationship between data science and machine learning. So now we have four circles here, or four sets here. As you can see, artificial intelligence is the orga at the top, right? So artificial intelligence is the field, a field on its own. AI is a field, right? Inside that AI, we have machine learning. So machine learning is a technique that is used in building artificial intelligence products or services or computers, right? The AI stuff we see today, like ChatGTP. ChatGTP is built using machine learning, right? And so many other things that you might have interacted with that is intelligent. So any computer that can perform that can perform task that requires intelligence we actually regard it as an artificial. We generally regard that intelligence as artificial intelligence. So we have human intelligence and we have artificial intelligence. The same way that we can look at something, right? We can look at an object and we can know what that object is. And based on what that object is, we can react to it. So, for example, you are going on the road, and let's say you are just walking by, and you see something like a wild animal just running towards you. You see the wild animal it's an object. So in this case, anything that we can visualize is an object, whatever it is. So that, just understand that. So we see that wild animal as an object. Based on our intelligence, we already know that this object we are seeing is a wild animal. And now, based on the information we know about the wild animal, we now take an action, which is evading the wild animal or running away. So we're actually performing an intelligent action, right? That is an intelligent action in a human sphere. The same thing with communication. What I am doing now, I am communicating with you. I am uttering words, right? That is moving as sound waves through my computer microphone and coming out your speaker. And you are perceiving it and you are understanding what I am saying and it is making sense to you and you are making sense of everything I am saying. that is intelligence happening in action. So if I ask a question now, right, you would answer in the group chat. So you understand what I am saying and you are replying. So that these things are actually intelligent actions. So all these actions that human can do, all these basic intelligent actions, is what computer scientists or people are now trying to replicate in computers, so that computers can now on their own too do or perform tasks that looks looks like they are using intelligence, like an intelligent, that they perform tasks that requires intelligence, a level of intelligence to perform. So for instance, if you ever asked ChatGPT a question, you this it is basically exactly how a human will respond. You ask it, okay, why is this so and so, or explain this, or you just ask it a random question. It is able to understand what you said. First of all, you understanding is also, it also requires a level of intelligence, and also give you a response. So that is an intelligent action. So that is what artificial intelligence is, trying to replicate human intelligence in computer, so that that techniques that are used to perform or to carry out or to achieve this task. So now machine learning is one of them. So machine learning is very, very vast. There are a lot of things we can discuss as regard that. But for the sake of this particular course, we'll just be looking at the fundamentals, right? So I just want to give you an idea of AI and machine learning. So even if we don't really talk about or look at everything, you have an idea of it. So it will not be new to you as you're moving out of this program. So machine learning is a technique inside artificial intelligence. The aim of artificial intelligence is to create a system that can perform like human, right? That is the aim. So we can we can create like self-driving cars. Self-driving cars are they it basically mimics human driver. So the car will drive itself like a human being would do. So it is able to identify red light, is able to identify when a person is crossing the road, is able to know when to speed, is able to know when to slow down, is able to know when to park, is able to know when to do all these things. So that is the very intelligent action. That is one of the application of artificial intelligence, self-driving car. We have a lot of them outside there, if you've heard of Tesla. So these are the things that AI is trying to achieve. The same thing like let's say a robot that can assist you. Although there are robotics is a different field, but there are robotics that are merged with AI. So the robot can actually act like a human in assisting you with specific tasks. So I don't go deep into the different kinds of artificial intelligence. That is not the purpose of this class, but I just want to give you an understanding of that. So now we look at machine learning. Now machine learning is now a branch, a subset of artificial intelligence that focuses on using data to train a computer. Now, this is what we are doing today, machine learning. So I'll make sure I take my time to explain this one for you. So before we explain that, just look at, we have another one here, deep learning. Deep learning is a subset of machine learning. Inside machine learning itself, we now have deep learning. So that one is even more complicated kind of machine learning. We're not going to do that one. Like, it is out of scope, entirely out of scope. It is a very advanced and complex this thing, part of machine learning. So if once you finish this, you can go on to learn it. Once you understand machine learning, deep learning should not be difficult for you. So we also have data science. As you can see, data science is by the side here. So data science is taking a portion from all these different fields. So now data science is not artificial intelligence. Data science is not machine learning. Data science is not deep learning. Data science is a field on its own that combines statistics, combine mathematics, combine machine learning, right, to make sense of data. So as you can see, it is taking if you understand sets in mathematics, so this is basically taking a portion of this particular field. So this should give you a better idea of where data science falls in machine learning and artificial intelligence, right? So now for machine learning, I've talked about artificial intelligence. So what is machine learning? machine learning is basically using data to train a computer so that the computer will look for patterns in the data and able to make predictions when next is see that kind of data, right? So let's assume you give a computer the picture of a cat, right? You give the computer the picture of a cat. The computer, the algorithms that will be applied to it, that will be used to understand the features of that picture, how the things that make that picture unique, and that makes that cat picture of a cat. So it looks at all these things and creates a model. All right. So when next it sees a different picture, it is able to say, yes, this is similar to what I have seen before, and it's going to give you a prediction. Yes, this picture I am seeing now is a cat, but it has not been exposed to that picture before. That is basically what ML does, but that is a higher level this thing, and it's more relatable. That's why I'm using it. But in machine learning, we give the machine, the computer, plenty data, a lot of data. The same way as a child, when you give birth to a child now, the child doesn't know anything, right? The child is introduced to the world without any knowledge at all. So day by day, the child now, as when the child starts seeing, the child begins to take in data from the world, right? It begins to take in, see a lot of things. Little by little, it sees picture colors. He or she sees shapes, sees a lot of things, and the child brain is building a model. As it is taking all this data every day, it is building a model of different objects and the model of the world. So it is able to interpret or understand what it is. So that it takes a long time. That's why when you give it to a child, the child does not automatically become intelligent. So the intelligence requires data. So for a human being, the same way intelligence for a human being requires data, it's the same way intelligence for a computer requires data. But the data we give it is quite different, right? So for a human being, we collect data via our eye, via our sensory organs, right? Basically, our eye and other sensory organs. So whenever we see something, we're able to start to make sense of it, categorize it, just understand how it relates to every other thing, and act accordingly in with regards to what we are seeing, right? So it's the same way a baby grows by looking at data and taking it. It's the same way a computer too learns by looking at data. So by the time your child gets to 1 year, the child has already taken a lot of data. He has touched a lot of things. He has seen a lot of pictures. He has seen animals. So let's say for the first time when the child sees a cat, probably he doesn't know that, or maybe he sees a wild animal or something that is dangerous. He won't know that this thing is dangerous, right? Because he or she has not seen it before. But once he interacts with it and there's a kind of negative feedback, it begins to readjust. It begins to learn from those data. It begins to learn from experience. So it is a very complex system for human beings. You can't really understand how it is done, right? So the same way a child learns is the same way a computer learns. So we feed computer with lots of data. We just give it data. Oh yeah, from this data we are giving you now, try to understand the relationship in this data and model it for by yourself. Although we are giving the computer data with an algorithm. So the data is not just there. There are algorithms that are used to work on this data, right? So we're going to look at some of them. So the computer takes in data plus algorithm, and it gives us a model. So that model is what we can now use to do a lot of these predictions, to do a lot of these tasks that we see, and a lot of other machine learning things, AI stuff, right? So it is a very, very interesting field. It's a very interesting. But what you have to know is that machine learning requires lots of data plus algorithm. Data plus algorithm. Note that machine learning is equals to data plus algorithm. If there's a formula for it, that is the formula. So I wish I had that here, but there's a particular image I was supposed to put here to show you exactly what I mean by that. Right. So because of time, let's just move on. So we have types of machine learning. So I've tried as much as I can to just give you an idea of what machine learning is. It's the ability of computers to learn from data, right? So, but we have different kinds of machine learning. We have supervised, let me zoom this in. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. Now, these three big types, they are fields on their own. I've been saying this since like almost everything we are doing. They are like it can be a field on its own. So supervised learning is what we are going to be looking at mostly, right? Most of the machine learning and AI stuff we do is mostly supervised learning. So we also have unsupervised learning, and we also have reinforcement learning too, right? So this reinforcement learning is usually used in robotics, right? So it's usually applied in when you want to build a robot that can navigate the world. So that is where it is. So it's not something we are going to be looking at a lot, right? So supervised learning is what we are going to be focusing on. So from here we said that this involves training a model on a labeled data set. So now you have to understand this labeled data set. That is what makes supervised learning supervised learning. You remember I said that when we want to like train a machine to understand, let's say, the picture of a cat, right? We can we can say that, or we can give it a picture that is a cat picture, and we are going to label that picture as cat. We'll give it a lot. We can give it like 10,000 pictures of a cat and label each of them cat, 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 cat. This is cat. This is just like teaching somebody, right, by instructing them and telling them exactly what this is. So you are supervising the machine by giving it labels. So you're already telling it what this data set is. So sorry, I'm using this particular example, picture of a cat. So that is actually a more familiar analogy, right? But the one we're going to be doing, is mostly going to be numbers, right? We're going to get there, but just understand what I'm trying to say. So you label the data set, and maybe you say you give it cat, 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 cat. You now give it dog, dog, dog. You now give it dog pictures. You now label it dog and everything dog. So what the machine will do is that it gets this two data, the data itself, that is the cat picture, and the label. So it is able to make once it is trained first on that data, it now takes the prediction it makes and compare it with the actual label of that data set, and the differences in what the computer predicted and the actual truth is what we call an error. So that error is what the computer now tries to reduce. So there's an algorithm that we use in reducing error. We're going to talk about that. There are a lot of things we are going to introduce in machine learning. So please don't get intimidated. Just brace yourself. Like see it as a new adventure, something new, right? So the same way when you started data science, you didn't know a lot of things, and now you already know a lot of things. The same way now you are starting machine learning, you didn't know a lot of things, but in the next 5 weeks or 6 weeks, you are going to be very comfortable with it. You'll be like, oh, was it that thing I was finding difficult to understand? So please just pay attention. If you decide, or if you've told yourself already that this thing is hard, I can't learn it, you will not learn it. That is just the truth. But if you tell yourself that okay, I'm just starting, I don't really know this thing now, but with time I will understand it. Definitely, you're going to understand and you're going to get comfortable with it. So just have that mindset, right? Because the truth is that this machine learning can be a little bit daunting, right? It can be a little bit daunting. So, but I believe with consistency, you are going to get a lot out of this. So now we are talking about supervised learning. So you need to know these two things: labeled data sets. So your data sets are labeled, right? They are labeled. And for this supervised, we have different kinds of algorithms we use for it. We're going to talk about that, right? So just know that this involves training a model on a labeled data set where the correct output is known. Have you seen it? Where the correct output is known. And the goal is for the model to learn a pattern that maps inputs to the correct output, right? Input to the correct output. I remember I said this thing when we were having introduction to data science. Like a model is a relationship between an input and an output. So when we have a model that we've created, that model basically is a knowledge. That model is a knowledge that we've trained, or that model is a knowledge we've gotten from the training we've done on the computer. So I've been using some words repeatedly. Training. I've been using training. So training is actually a concept in machine learning that means feeding data into your computer using an algorithm and then bringing down the error, or trying to make sure that the computer is able to accurately predict the exact label, the original label. So a machine learning model is not always 100% accurate, right? So the same way a human can make mistake at some point, right? It's the same way a computer too can make mistake at some point. So if you create a machine learning model, you don't expect it to be 100% accurate. So that is what most of the research that has been done in machine learning focuses on, trying to reduce the error, right? It's the same way that let's say we have a machine learning product or system in the healthcare industry that kinds of classifies tumor, right? Let's say it takes a picture of a brain picture. Let's say there's all these radiographers. There's a way they're able to get the picture of the cross-sectional view of the brain, and then read that particular image to know if there is a tumor in that picture. So in recent times, they've been able to develop machine learning algorithms or models that is able to tell you whether there is a tumor here or not. So that is an example of an application. So now, in this case, if there is a large error in the model, it is going to be very costly, right? Because there are cases where instead of the tumor will be there, but the machine learning or the model will not tell you that tumor is not there. That is an error. That is an error. So the model tries as much as possible to minimize the error it makes. So that is something, or one thing, that we are going to be working a lot as we start practicing machine learning in the subsequent weeks, right? We'll try as much as possible to reduce our error and increase the accuracy. The accuracy is basically saying if this thing is yes, then the machine will say it is yes. If this thing is no, it says no, right? So increasing the accuracy, right? So we are going to dive deeper into all this in the coming weeks. So common applications include spam detection and real estate pricing. So I've been talking about example like cars, the health sector, Sumo, and the rest. So, but the ones we will most likely be working on is something like spam detection or real estate pricing. So in this case, now, this is supervised learning problem, right? It's a supervised learning problem, or it is we use supervised learning machine learning, supervised learning to solve this problem. So spam detection is basically telling you whether an email is a spam or not. You know, if you have a Gmail account, Google automatically categorizes some emails as spam. You are not the one to do that manually. So that is machine learning in action. So as you are receiving an email from a sender, it goes through Google model, spam detection model. So once that email enters that model, the model is able to tell whether that email is spam or not. That model has been trained previously on a large number of emails, spam and not spam. So it is able to learn the relationship between an email and whether that email is a spam or not. So we don't really know how the computer does all this or maps this relationship, but we know that it is able to predict these things with a certain level of accuracy. So sometimes this spam detection makes mistake. That sometimes I'll check my email address and I'll go to my spam and I'll see emails that are actually not spam, right? So I'm going to have to remove them from spam. So that's the kind of error, or that is the kind of that is what we see as an error in in a particular model. So they are not always accurate, right? So also real estate pricing is also a kind of application. So in this case, we can actually have maybe a particular house, and for that particular house, we'll have a lot of variables. So for that particular house, we can have number of rooms. For that particular house, you can have the location. For that particular house, you can have number of toilets. For that particular house, you can have a lot of things that pertains to the house, right? So that those are the variables in the house, and the label will now be the price of the house, right? Whether the house is let's say 500,000 naira, 250,000, 350,000, 420,000, right? So machine learning is also able to predict the prices of a house based on the variables you give it. So for it to be able to do that, you have to train it with a lot of real estate data. You have to get a lot of data that has information about the house, rooms, number of toilets, the size of the kitchen, and a lot of other things, right? So it maps a relationship between the variables and the output, right? And it is able to predict on something or a data that it has not seen before. If you give it a data now, like a model that has been trained on real estate houses to give you the price, and you have a new data, you want to know how much the potential price of that house, you can put in the information into that machine model, and it will give you an output. Okay, this is the estimated price of this particular house. So that is an application, right? So even in supervised learning, we have different kinds of machine learning under that. So we're also going to talk about it. So for unsupervised learning is the opposite of supervised learning. So unsupervised learning, it deals with unlabeled data. Okay, let me be sure you're still following me. Hope everyone is still hearing me loud and clear, and network has not done its thing. All right, all right, great. Okay, so unlike supervised learning, unsupervised learning deals with unlabeled data, right? Unlabeled data. So in this case, the model tries to find the underlying structure or distribution in the data to learn more about the data. So now we are now leaving the computer to learn on its own, like without supervision, right? We are no longer giving it labels, whether this is a cat or this is not a cat. We're just giving it images, or we're just giving it data, or we are trying to figure out something from this data, right? Although there are specific use cases of unsupervised learning. So, but basically, it doesn't get a label. So you need to understand these two different things: labeled and unlabeled, right? So supervised learning usually use data sets that are labeled, while unsupervised learning use data sets that are what not labeled, unlabeled. I'm going to give you an assignment on this. It's just going to be a quiz assignment, right? So it's just going to be a Google form just to assess your knowledge on what we've done today. So please pay attention to some of these key things I will be saying. Some of the things I might even ask might not even be in this notebook, right? So please just pay attention. So now we also look at, so still on unsupervised learning, we have clustering and association. So we can have maybe we're in a business now. We are running a business and we have customer data. We have a lot of customer data, and we want to categorize these customers into different groups. Maybe let's say based on the price, or how much they spend in buying our products. So unsupervised learning can actually find relationship between different customers and group them separately into different groups, right? So it just that you're not supervising, you're not giving it any label, you're not saying that this customer is top class customer, this customer is low. So it is going to on its own categorize these customers into different groups and categories. So that is an example. Actually, that is one of the common use cases of unsupervised learning or unsupervised machine learning, right? And then reinforcement learning. So reinforcement learning is, as I said before, is basically trying to build a system or an agent. An agent here is like a robot that can interact with an environment in an intelligent way. I don't know if you've watched videos of robots that are actually behaving intelligently, like they are walking like humans, they are dodging obstacles, they are jumping whenever they see a pit, or they are doing things that you would not imagine a normal computer to do. So this is an application of machine learning. So we train these agents to behave in an environment. So this is actually a very separate, or this part of machine learning is not very much interacted with, right? The ones that most people are conversant with are supervised and unsupervised learning. So reinforcement learning is not really practiced a lot. It is mostly in industries or big companies or in research. Like for example, now I don't know if you know about Mars, exploration in Mars. NASA, the people or the agency that is responsible for space exploration, they sent in a robot in Mars. Mars is another planet. So they sent in a robot to another planet to kind of explore the planet and to just figure out the things, the elements, the materials in that planet and send back data to Earth. So how they built that, they used machine learning in building that robot because the robot is going to be on its own in that environment. So they need to train it to be able to interact with an environment in an intelligent way. So it doesn't just go there and it will reach a particular point, and then because there's an obstacle there, it cannot move again. No, right? So it will be acting like a human being. When it meets an obstacle, it will go back and then move. So there are a lot of things that is involved in reinforcement learning, right? So just understand that we will not be touching reinforcement learning in this program. So what we'll be looking at mostly is supervised learning, right, and a bit of unsupervised learning, right? So that is it for that. So you can see the graph here or the diagram picture here showing you the types of machine learning. We have supervised, unsupervised, and reinforcement learning. So supervised learning is task driven, right? You have a particular task you want to achieve. Unsupervised is, as you can see here, identifying clusters. We are just allowing the data to learn patterns and group the similar data points together, right? So reinforcement learning, as you can see here, it's even represented by a robot. It learns from mistakes, right? It learns from mistakes. So, right, so these are the major types of machine learning, right? Now we're going to look at the steps in a machine learning project. Steps in a machine learning project. So the typical life cycle of a machine learning project includes several stages: data collection, right? I remember we talked about data science life cycle. This is almost the same thing as the machine learning project, almost the same thing. So you collect your data, you preprocess your data, you select your model, and then you train the model. Now you see that there is there's a step missing here that we don't pay attention to, like the EDA, right? The EDA. So we in machine learning, you just go straight to training your model, right? Like you select the model you want to use, and then you train it, right? So these are the steps you use. So you collect your data, gather the raw data from various sources, data preprocessing, cleaning and organizing data into suitable format for analysis, model selection. You choose the appropriate model based on the program type. So now there are lots of machine learning models. There are a lot of them, right? So we can't actually exhaust the amount of or the number of those that we have in machine. But each of these algorithms, there are a lot of algorithms. Each of these algorithms have a specific use cases. They have specific use cases. So as you are moving, you are going to understand how to apply the appropriate machine learning algorithm to the appropriate task, right? You're going to learn how to do that because you don't just use any algorithm that comes your way. But as you move on, you begin to understand everything better, right? So let's just move on. Now, after you've selected the model, you then train the model. So basically, in training, you are teaching the model to learn from the data, right? To learn patterns from the data. After you've done that, you evaluate your the accuracy of the model, right? So this actually takes a lot of attention and time, because you need to make sure that your model is accurate enough and it's not just giving you rubbish answer. So these are the steps that you would mostly come across during your machine learning project, right? So now after that, then you now deploy your model in a real world application, right? You deploy your model because you are not just going to train the model and keep it in your computer. No, you need to put it out there so people can use it for their various tasks and to solve their problems and to do a lot of other things, right? So that's basically it. If you were in the first class, this shouldn't be a problem because I explained that. So this is a diagram explaining the steps in a very more compact. So training data, you use your algorithm, you learn, and then you get your trained model, and then you can use it to get results. So this is basically the machine learning process, right? So now we're going to be looking at core machine learning algorithms. So I'm just going to be explaining them, like just the surface level explanation. And from next week, we'll be delving into them. All right, so these are the things, the several algorithms that we use in machine learning. So we have linear regression and logistic regression, right? Linear regression and logistic regression. So most of these algorithms that are under supervised learning, by supervised machine learning. So linear regression is a kind of algorithm or an algorithm that is used in predicting continuous values. Like for instance, when I talked about the real estate pricing, so when you have your target variable is what you want to predict in this case. While your predictor variable, there are things that will introduce. Predictor variable are the variables that are used to predict your target variable, right? So your target variable is also called your dependent variable, while your predictor variables are also called your independent variables. So these are some of the lingo you'll be using during the course of this machine learning. So the textbook I sent, let me see if I can open it. At the end of this class, I'll just go through so you see exactly some of the things that we've been talking about. So the textbook actually has a section on machine learning. So if you open it, you're going to see a section where and they talked about machine learning and a lot of other things. So you can just go there and read, right? Read, understand some of the concepts we've talked about today, right? So just brush yourself on it and so many other things, right? So well, you can just go through it. Because of time, I might not be able um, to show us that, right? So so linear regression is used to predicting when you want to predict a continuous variable, right? I'm not moving anything. Like it's here. It's I'm not making any movement. So now we also have logistic regression. So logistic regression is just like linear regression, but in logistic regression, we are trying to predict or we are predicting two categories, either yes or no, true or false, present or absent. Right? So in the cases where our problem, it requires us to know if there is a presence of tumor or there is no presence of tumor. We can use logistic regression, right? So those are the cases. There are specific cases where we use specific algorithms. My video is paused. Can you all see my video, my screen? Hello. All right. So So that's basically it. As you can see here, it is used for predicting continuous outcomes and binary outcomes, respectively. So linear regression is used for predicting continuous outcomes, while logistic regression is used for predicting binary outcomes. So just know that. So we also have other like decision trees and random forests. So these are algorithms too, right? These are different algorithms. So you would have a lot of algorithms that we're going to learn. So you can just basically choose anyone that is convenient for you or that is suitable for the task you are doing. So these are also used for classification and regression tasks. So now let me just quickly explain classification and regression tasks. So in machine learning, we have two kinds of tasks, right? We have classification problems or task. We have two kinds of tasks or problem. We have classification problems and what regression problem. So classification problem is the same thing as this binary outcome that we talked about. So it is when we want to the our task is to classify two categories, yes or no, this or that, A or B, right? So that's classification, right? So we can even classify several categories, more than two categories. So this is basically what classification tasks mean. So there are algorithms that are specifically built for classification tasks in machine learning. We also have regression task. Regression task is when we want to predict a numerical continuous number, right? So like prices of home, a lot of other things, right? Like you just any kind of problem that involves you to predict a numerical value, then you know that it is a regression task. And regression tasks have specific algorithms that we can use. So for classification tasks now, we use logistic regression for it. As I said, for regression task, we use linear regression, right? So linear regression. Forget that regression is here. Just forget this. It's actually logistic regression is actually an adaptation of linear regression. So classification tasks we use logistic regression. Regression tasks we use linear regression. So for decision trees, yeah, decision trees. So for decision trees and random forest, there are also algorithms that we use. You're also going to learn about them too. We're going to explain them in detail in subsequent classes. So these are also other algorithms that we can use in classification or regression tasks. So the same way we can use linear regression and logistic regression for both of them. So you can choose either this one, you can choose this one, you can choose this one. Like so, there are different algorithms that many people have built, many researchers have built. So we can pick any one that we want that is giving us the best accuracy. So the way we usually perform or do a machine learning project is by training the data on multiple algorithms and seeing the one that has the best accuracy and selecting the algorithm and using it in our work. That's how we do that. So we'll learn about several other algorithms. So we have support vector machine. So this is also another algorithms that is used in complex or in classification problems. So just know that. We have neural networks. So this is actually more advanced. We're not going to look at that. This is actually where we talk about deep learning. Remember, we talk about deep learning here. So deep learning is where we introduce neural networks. So that is actually a much more complex algorithm. So it is the basis for deep learning, and it is ideal for tasks like image and speech recognition. All right, so that is it for the core machine learning algorithms. There are also others we're going to introduce too in the course of the program, but these are the ones that we are going to be looking at, right? So now we'll also look at model evaluation techniques. So although this is not exhaustive, I will still add some more there. So we have several techniques that we can use to evaluate our model performance, right? So and this is all right. We're actually going to talk about this when we start, so you understand it better. But just understand that there are several ways we can evaluate our model. So for classification problem, we have several techniques for model evaluation. For regression problem, we have several other techniques too for model evaluation. So once we have trained our data, we've trained the model or with a particular data. we can now start to evaluate that model to ensure that it has a good accuracy, right? To know to ensure that it performs very well in real world situations. So that is what we do during model evaluation, right? So it's a very important stage. So once you realize that your accuracy is bad, you can now go back to training. You can maybe based on what you get or the information you get from this stage, you can add more data to your data set. You can do a lot of other things. So we're going to be discussing some things that we're going to be doing during our model evaluation. So we have things like confusion matrix. Like the first time I heard about this confusion matrix, I was like, why exactly they use the word confusion? And is it like, are they trying to make us confuse the word? The honest truth is that this confusion matrix can be confusing. It can actually be confusing, but it's just a 4 by 4, a 2 by 2 grid that tells you the false positive rate, the true negative, the true positive, false negative, and true negative. So it just gives you that and gives you. It's used for classification evaluation, classification tax evaluation. We have cross validation, right? So this is another technique we use. We also have ROC curves and AUC. So these are things, or these ones we mentioned that are basically for classification tags. We are also, I should have included regression tags, but this is not a problem. As we are moving, we're going to have to talk about all this in depth, right? So now, um, this is basically what we've said. So you can just go through that. So we have machine learning libraries, right? So we've talked about machine learning and we've talked about all the things that we can do, the algorithms, the evaluation, this one, the types, supervised, classification, and the rest. We have, how do we now implement it in Python? That's the question now. How do we implement it in Python? So the same way we have pandas, the same way we have NumPy, the same way we have matplotlib, we also have another library that can be used in doing machine learning. So it makes life easier, to be honest with you. It makes life easier. Like in 2 lines of code, you've done what you want to do, but there are a lot of things you need to understand. So we have the library, right? So the one that we're going to be working on in this program is scikit-learn. I believe I've said this several times, scikit-learn. So the learn here is basically for machine learning. So scikit-learn, the purpose is for general machine learning. So this is for the machine learning, the basic machine learning, and it's very robust. Like it has a lot of algorithms and it has a lot of tools that we can use. So it is for general machine learning, and it's a good starting point for anyone that wants to start with machine learning. So as you can see, scikit-learn is perhaps the well known or the most well known Python library for machine learning. Right, it provides simple and efficient tools for data mining and analysis, right? And as you can see here, our Oga has come back. It is built on what? NumPy. So everywhere you go, if you turn right, you see NumPy. If you turn left, you see NumPy. If you face front, you see NumPy. If you face back, you will still see NumPy. I said this, that NumPy is very core, is a core library in data science. So even if you don't use it explicitly, all the other libraries are going to be using are going to be using NumPy functionalities. So you need to know NumPy to be able to work very well effectively with all these libraries. So it's also built on SciPy. This one is you don't need to worry about that. It's another library, scientific Python. So it's also built on Matplotlib. As you can see now, everything is one family. Everything is interconnected. That's why you need to know them, right? So it includes support for various machine learning tasks such as classification, regression, clustering, and dimensional reduction. So we're going to learn a lot, like in the coming weeks. So this should give you an idea of machine learning and what to expect, right? I hope this is exhaustive. So we also have other libraries, right? But I'm just going to dwell on this. Scikit-learn. We have TensorFlow. So TensorFlow is another library in Python. It's basically used for deep learning and neural networks. So we won't be doing that, right? So it was developed by Google, and it's an open source for numerical computation and large-scale machine learning, blah, 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 and everything. So that's it for that. We have Keras. So this Keras and TensorFlow are actually together. they've been merged. So TensorFlow uses Keras API for all its functionalities. So we also have PyTorch. PyTorch is another library for deep learning, right? So it's not what we're going to be doing. And then we have XGBoost. XGBoost is a decision tree. Remember when we talk about decision tree here? So decision tree is a family of algorithms. It has a lot of algorithms on that. It has XGBoost, it has other boost, it has gradient boost, it has random forest. So, and these are very, very good algorithms that we use. They are very, very good. In competitions, people use this XGBoost to win a lot of machine learning competitions. So we would also, hopefully, if we have enough time, we'll also look at XGBoost, right? So the explanation is here. It stands for extreme gradient boosting, blah, blah, blah. As you can see, it is an implementation of gradient boosted decision trees, right, designed for speed and performance. So these are the things that we're going to be looking at. So we have gone through the entire scope of machine learning and what we are going to be doing in the coming weeks. So brace yourself, brace yourself. We are stepping into a new level, a new level. So if you don't understand all the things we've done so far, please use this week to understand it very well. Use this week to go through the videos that you've not understood, pandas, numpy, matplotlib, read. Try to, because as we are moving now, if you don't understand some of these previous concepts, it will be difficult for us to move ahead, right? So do yourself a favor and get yourself prepared. There are materials out there. Please, I will resend the PDF again to the group chat in case you missed it the first time. So you can go there and read through it. You don't need to read every single thing, but just try to look at one or two things, try to understand what they are saying there. Go on YouTube and type machine learning. You'll see a lot of videos, or just type introduction to machine learning. In case you need additional explanation, you see a lot of videos that explains machine learning, so you can gain a better intuition and clarity, right, on machine learning itself. So as we are moving ahead, you'll be flowing and everything is going to be going smoothly. So we've come to the end of today's class, right? We've come to the end of today's class, and I'll be opening the floor for questions. So please, if you have any question, raise your hand and I will unmute you. All right. I don't know how to pronounce your name. Edem Anwanabasi. I'm so sorry if I didn't pronounce that very well. Please, you are mute now and you can go on to ask your question. Hello? Okay. All right. Udofia, please go on to speak and ask your question. You're on mute now. You can unmute yourself and speak.
Hello. Hello, can you hear me, sir?
All right. Yeah, go on to ask your question. I can hear you.
Okay, thank you so much. Thank you so much. This my first question is, why is machine learning both simple and complex? That's number one. The second question is, what's the difference between the machine learning and the traditional programming?
Okay. All right. Thank you very much for that question. So there's actually a picture I'm trying to get that explains this concept very well. It explains it very well. So just give me a minute if I can just get that. Because a picture is worth 1,000 words, and yeah, so that's going to help explain very, very well. So just give me a minute, please. Just give me a minute. Give me a minute. Give me a minute, please. But for your first question, you were asking why is machine learning um both easy and complex? I don't know if I get that very well, but I think it's actually both easy and complex, right? Because it's actually something that you don't need to put so much effort from your end. You just need to get data, get your algorithm, and just do a lot of tweaking, right? Model evaluation, pre-processing, and a lot of things to ensure that your model is accurate. But it's also complex in the sense that there are a lot of things to understand, a lot of concepts, mathematics, some things, dimensions, matrices. These numpy arrays we learned, you need to understand it very well to be able to um, work well with in machine learning. So because in machine learning, we work with arrays. Anything we are doing, we convert it to numpy arrays. That's why I told you that numpy array is the building block of every other thing. So every data we're going to be passing in, most of them are numerical data. We don't pass in string into machine learning algorithms. It will give you an error. So you need to understand how dimensions in machine learning and all those things. So that is the complex part of it. But the implementation part of it should not really be a problem. So now let me quickly show you something. Right, this was a post I saw recently. So can you see the screen? Now, as you can see on the screen now, we can see traditional programming and we can see machine learning, right? So this traditional programming is how we code. When we code, we write a program to a particular we use a data and write the program to that particular data, and we pass it to the computer. So the computer figures out computer uses the program we write, applies it to our data, and give us an output. So there is a lot of work we're going to be doing in terms of the programming, right? So there's a lot of work we're going to be doing to code. But in machine learning is the reverse case of traditional programming. In machine learning, we are basically just giving our computer, the data and also the output. This output now is what we call label. Remember I said labeled data set, and so this output is the label, that thing that it should know, it should predict. So we give it our data and our label. So the computer figures out the relationship between this data and this output, and it gives out, this program is basically the model. The model is the relationship between this data and output. So you can use this model to you can apply it to subsequent data that it has not seen before. So this is the differences between traditional programming and machine learning. So for instance, now let's say we want to identify a cat, and let's say we want to use traditional programming to identify a cat. We can come and now start saying using if else statement. Okay, if this particular cat or this particular picture has 2 years, then you give it 1 point. If it has paws, you give it 1 point. So you basically use if else statement to figure out all the features that makes a cat a cat. So it can be tasking sometimes, and sometimes every cat, some cat has slight differences. So you cannot really capture the entirety of cats. So we are limited in that aspect. So, but in machine learning, instead of writing that if else statement and giving it the instruction, we can just give our data, bring our data, which is plenty images of cat, plenty of them. And then we're going to label it cat or not cat, cat or not cat, cat or not cat. And we're going to pass it with an algorithm. The algorithm is what is going to map out the relationship between this data and the output and give us a model and output. So that model is what we're now is now the knowledge of this particular problem that the computer has. So we can use it to make predictions and do other things. So this is just the difference between the traditional programming and machine learning. Yeah, thank you for that question. I actually wanted to show us this this image initially. So yeah, I hope you are clear on that. Like, I hope you are clear on that. You can unmute yourself and all right. So And someone was raising up their hand initially. Udofia, I don't know why you put down your hand. Okay. So Ademoye, please go on to speak and ask your question. Ademoye. Edem, hope you are cleared on your question. I've not gotten a response from you yet. Yeah, Ademoye, good evening. I
Thanks for
can hear you.
the class. We really appreciate your teaching. So actually, my question is based on the overall data analysis and others. So after we compile after we design all our visualizations and other things like that, how could we bring them together in a kind of dashboard or a sharing things? So I think you get my question clear.
Yeah, I get your question.
Yeah. Is
So,
there a way to bring them together in Python?
yeah, so what you're talking about is basically for visualization. So in analysis, data analytics, once you're done with your visualization, you put them in a dashboard, right? And then you present it to whoever it is you want to present it to. So you can use several tools
Okay.
that is not Python to do that. You can use Tableau, you can use Power BI, you can use Excel, right? So that is the presentation aspect of it. But in Python, you can as well do the same
Okay.
thing. You can create dashboards in Python, and but this requires different tools, right? So Matplotlib is not built to create dashboards, right? Unless if you are a data analyst, then you can explore other tools. So we have Dash is a library in Python that can be used to create interactive dashboard. We have Plotly that Plotly is also used to create different visualizations. We have so many libraries. Dash is one popular one. I'm trying to remember the other one. Okay, but you can just look them up. There are other ways we can present that in Python. But for the purpose of this program, we won't be doing dashboard presentation, right? That is not the goal of data science, at least, yeah. So unless you are doing data analytics, then we can now focus on creating dashboards and then sharing that with people and stakeholders. So I hope that answers your question.
All right, sir. Thank you very much.
Okay, so Udofia, please, you can go ahead and ask your question. You're on mute. You can ask your question. We're waiting for you, or should we call it a day?
Hello, sir.
Yeah, I can hear you.
Good evening. Okay, sir. Thank you for the wonderful session.
Yeah.
Please, sir, some of us we were not really good in mathematics, and you can forget most of the things. I think you will have explained a little more on these logarithms.
Do you mean
Hello?
algorithms?
Yes.
Okay. So one thing about machine learning that you probably have heard is that you have to be good in mathematics and everything, which is very true. You need to understand maths, at least a certain aspect of mathematics, to be able to understand what your machine learning is doing, right? But we have scikit-learn, which is a library, and the scikit-learn library has abstracted all these complexities into a function. So instead of doing all those going through a rigorous process of defining mathematical functions, you can just call a function in scikit-learn and you pass in your input and you make sure that your input is the right input, it has the right dimension and everything, and your code will work, right? So it makes life easier, as I've said. So you need to understand a level of mathematics to understand some things that are happening in your machine learning, but you don't need to be an expert in it to be able to do machine learning. Unless you want to go into the research aspect of machine learning, then you have to be very good in machine learning. But if you just want to be using it, you don't. There are people that didn't like maths and they are doing data science and they are doing it very well. So don't let it intimidate you, or don't let it be a setback. So yeah, that is it for. I hope you're clear on that.
Okay. Yes, sir. Thank you.
All right, Omalade, you can speak.
Okay, good evening, Mr. Emmanuel.
Yeah, good evening.
Thank you for the class. I really
Yeah,
enjoyed the way you are teaching because for some of us that we are not from the computer background, is really explanatory. But my own question is, we understand NumPy, we understand pandas, but what's the application of machine learning? In what aspect can we apply it? That's
okay, okay. You were here in the class, right? Like, did you go out at any point?
no, I didn't.
Okay, because I believe I explained some applications during my explanations. I gave some instances of where you can apply machine learning. When I talked about cat identification, when we talked about real estate pricing, when you want to predict the prices of houses. I also talked about a situation in healthcare where you want to
Okay,
predict
okay.
or
That's
show
true.
if a tumor is present in a picture or not. I also talked about spam detection when I talked about email, right? When you get an email, Gmail can actually classify the email as spam or not spam and move that email into your spam folder or retain it in your normal folder. So there are so many applications of machine learning. But as we are moving, we are going to be exploring some of them and even implementing these using them in using these algorithms and implementing them. So yeah, you can actually still go back to the class and you'd understand better what I've
Yes.
said in case you missed it.
I can remember you talked about that. And I've even used one app concerning the real estate before.
Exactly,
Thank
exactly.
you.
So most of us have interacted with machine learning applications or apps out there, but we don't know that it's machine learning. So it makes life easier. That's just the truth, right? Instead of going through the rigorous process of doing things, you just let the computer do it. So people have trained a lot of data, and then they can use that model they've trained to just simplify tasks for us, right? So that is the beauty of machine learning. It's a very very beautiful field. So you enjoy it definitely. You enjoy it. So I hope that has answered your question, Amalade.
Yes, it has. Thank you.
All right. All right, Zaifa. Yeah, you can go on to ask your question. Jean Zaifa. Don't know if I'm pronouncing that correct. You're on mute now. Please go on and ask your question. This is the last question I'll
Okay,
be taking.
okay, sir. My question is, we actually haven't gone deep, but I want to ask this question because I actually have a problem somewhere. So, in a situation whereby you train the data set after the training and then you want to test your prediction, let's say it's a prediction model that's trying to predict something, and you gave it the input and the output are not coming out in the way you expect it, because this one you already have your data and you've assigned your output to your input, and then you're given the inputs. Now you're expecting the output, but then the outputs are not accurate. In this way, how do you deal with it?
Yeah, that's actually a fundamental problem that is faced most times during machine learning. Is a problem of accuracy, right? You want to ensure that your machine learning model is accurate enough to predict the right output to give you what it is you're expecting. So once you come across a situation where it is not giving you the right output, that is, you are not done. You are not done. So you are done with machine learning project when you've gotten to a certain level of accuracy. So during the training part, and the model evaluation part, you are going to do a lot of work. So when you train your machine learning model with your input and output, and then you bring in another set of inputs, right? And you give it to it, and it's giving you something different. Then it's pointing at something, right? Your model is not accurate. You need to go back and tweak a lot of things. So that is what we are going to be discussing over the course of time. There are a lot of techniques you can use. There's what we call variance and bias. And if your model has high variance or high bias, there are certain things you can do. You can add more data, or you can reduce your data, or you can tweak your hyperparameters. There's so many things that can be done to ensure that your model is getting enough accuracy, right? That is where most of this work is spent in machine learning. The same way most of the work is spent in data cleaning to get a very good insights from your data. It's the same way a lot of work will be spent in machine learning to make sure that you get a good accuracy, right? So it's not something we can discuss now. It's something that as we move on, you are going to understand how to approach them. So just make sure that you are in class and you are consistent. You are consistent with the class. Basically, you get your answers. You get answers to all those questions.
Okay,
Are
sir.
you
Thank
good?
you, sir. Yeah, I'm good.
All right. So we'll be coming to the end of this class, and yeah, so we have actually been able to talk about machine learning, and I just believe we've gained intuition on this. Like, if you haven't, that is fine. You can still go back to the video. This video is recorded. I will drop it as soon as I can. You go back to it, watch it again, learn it. You can even use external resources. Go to YouTube, go to websites, and just make sure that you understand this thing before next week, because we are going straight into the machine learning itself using scikit-learn, right? So thank you very much for your time, and enjoy the rest of your day. So please just let us know in the group chat if you enjoyed the class and what exactly you picked from this particular class. Thank you.